Samsung is not charging and not turning on. Today we are going to see two faults at the same time. This is one of the most frustrating failures for technicians. We are going to solve this problem step by step using real electronic diagnostics. No guessing, no randomly replacing parts, no wasting time. We go straight to the root cause of the failure. We begin by disassembling the device. We apply heat between 80 and 90 degrees Celsius to safely remove the back cover. This step is important to avoid damaging the glass or internal components. Once the cover is removed, we take out the screws and access the motherboard. Now, the diagnosis begins. We use a bench multimeter to measure the voltage at the battery connector. To perform measurements, you can even start with a simple $5 multimeter. At the beginning, there is no need to invest a lot of money. This is the first point we must check when a device does not turn on. As you can see, the voltage is insufficient. In a properly working device, this connector should have approximately 4.2 volts. But in this case, the voltage is much lower. This explains why the device does not have enough power to boot. We continue. Now we measure the voltage on the flex cable that connects the motherboard to the charging subboard. Here we should have approximately 5 volts coming from the charger. This voltage powers the charging circuit and allows the battery to recharge, but we have no voltage at all. This clearly indicates that power is not reaching the motherboard correctly. The next step is to check the charging module to see if it is receiving voltage from the charger. We measure the voltage directly at the charging connector. Here, we do have the correct 5 volts. This is good news. It means the charging port and charger are working properly. Now, we know the problem is between the charging connector and the motherboard. To confirm this, we install a new flex cable from our lab and repeat the measurement. Now we have a correct 5.2 volts at the end of the flex cable. This confirms the problem was in the flex cable. We reassemble the device for a real test. The phone begins charging correctly, reaching a current draw close to 1.7 amps. This is a normal value. It seems the problem is solved, but a new symptom appears. The screen shows no image. And when we slightly press the connector, a pixelated image appears. This behavior clearly indicates a connection failure in this plastic connector. This is where electronic diagnostics makes the difference. The fault is in the FPC connector soldered to the motherboard. This connector is responsible for transmitting both the charging signal and the display signal from the screen connector located at the lower part of the device. When this connector has a bad contact, the device may not charge, may not turn on, or may not display an image correctly. It is time to repair it. We apply flux to protect the pads and use a hot air station at 380 degrees Celsius with 40% airflow. We carefully remove the damaged connector. This process requires experience and precise temperature control. Once removed, we clean the pads and apply fresh solder using a soldering iron. Then, we apply heat again to level the surface. This ensures the new connector will sit perfectly. we place the new connector in its exact position. We apply heat evenly, reducing airflow to prevent the connector from moving. We lower the airflow to 15% to avoid melting the plastic connector. Once the solder melts, the connector is perfectly soldered. Now comes the final test. We fully reassemble the device and connect it to the charger. The phone charges correctly. The display works perfectly. The repair has been successfully completed. This type of work requires extreme precision. An FPC connector can have more than 40 pins on each side. Each one is extremely small. Even a minimal movement can require restarting the entire process. Behind every repair, there are years of experience, diagnostics, and precision. Microelectronics allows us to recover devices that years ago would have been considered unrecoverable. Remember this: technology has advanced to an extreme level. Today, repairing a phone requires the ability to solder copper wires that are 2 or 3 times thinner than a human hair. This is modern microelectronics, and it will continue to advance. And here, in this image, I am demonstrating it to you. This was today's video. I'm Leonardo, and I'll see you in the next one. Ciao!